chemical properties of alcohols. There are 4 reactions of alcohol. First one is reaction with sodium, esterification, dehydration, substitution reactions, and finally oxidation. Let's look at the reaction with sodium. The reactant are alcohol and sodium. So here we have alcohol over here. We remove the hydrogen, means it will become H+. So over here, alcohol acts as an acid. Why? It is because the alcohol is able to produce H+, hydrogen ion. So that's why we call alcohol can act as an acid, because it is able to produce H+. Reacts with sodium metal, and then the products are sodium alkoxide. This Na will form bond with the oxygen. It will become O- and Na+, sodium alkoxide over here, plus half H2, hydrogen, half because we only remove one hydrogen atom. So here half H2 means the hydrogen gas is produced at the end of the reaction. That's what happened in the reaction with sodium. So here example ethanol, just remove one hydrogen from the OH group, replace with Na, so it will become O- and Na+. Make sure you write down O- and Na+, because this is not a covalent bond, it is ionic bond, so O- and Na+. Second reaction, esterification. Alcohol reacts with carboxylic acid, we call it esterification. The condition must be reflux and catalyst. Reflux or heat. Reflux means slowly heat, or you can put heat, or you can write down reflux word. The catalyst is H2SO4 acid. Make sure in esterification you use reversible arrow, because the products can become the reactants again in esterification. So here we have carboxylic acid, acetic acid reacts with ethanol. In carboxylic acid, we remove OH. In ethanol, we remove H. So the side product will be H2O, because you remove OH from carboxylic acid, remove H from alcohol, making side product H2O. Make sure you don't interchange the removal of carboxylic acid and alcohol. Don't remove H in carboxylic acid, OH in alcohol. That's wrong. The OH will remove from carboxylic acid and the H will remove from the alcohol. And the place where you remove, for example here we remove OH at this carbon and you remove H at this oxygen, make sure you attach those two to become ester. So this carbon will form bond with this oxygen, like this. Where you remove, that's where you have to attach. Don't attach this carbon with this oxygen. Wrong. You have to attach the carbon that is involved in the removal of OH, attached with the oxygen that is involved in the removal of H. That's where the position you attach. Okay, for here benzoic acid, you remove OH from carboxylic acid, remove from this carbon. Make sure this carbon will attach to this oxygen that you remove hydrogen from the alcohol. So this is the position of the bond that will be formed. Where you remove, that's the bond where you will form it. That is esterification. The third reaction of alcohol is dehydration. So the reactant is alcohol. The condition is heat and the presence of catalyst concentrated H2SO4 acid catalyst. Products will be alkene and water. It has to follow Sizeth's rule. Okay, this alkene, most stable alkene, remember Sizeth's rules, in an elimination reaction, the most stable alkene is the most highly substituted alkene. Means C double bond C has the most number of alkyl group attached to it. That is the most stable alkene. In dehydration, remove one hydrogen, remove one OH. So the side product H2O. This is dehydration reaction. For example, ethanol. In the presence of catalyst concentrated H2SO4, heat, remove hydrogen, remove OH, and the product alkene, side product water, same goes to cyclohexanol. Remove one hydrogen from one carbon, remove one OH from another carbon. In the presence of catalyst concentrated H2SO4, condition heat, cyclohexene will be produced, alkene, and the side product is water. Next reaction is substitution reaction using HX, PX3, PX5 or SOCl2. X can be Cl or Br. So alcohol, ROH, our alcohol, reacts with HX, PX3, PX5 or SOCl2 to produce haloalkene. If alcohol reacts with HX, our X, remember, can be Cl or Br. So this X will substitute the OH group in alcohol, becomes Rx and water. If it reacts with HX, if the alcohol reacts with PX3, one of the X will substitute OH, it becomes Rx, and the side product is H3PO3. Okay, H3PO3. This is the side product. If alcohol reacts with PCl5, only one Cl used to substitute the OH group, it becomes RCl. Side products are POCl3 and HCl. And if the alcohol reacts with SOCl2 in the presence of pyridine, only one Cl will replace the OH, one Cl will substitute the OH group, it becomes RCl plus SO2 plus HCl, side product. Okay, these are the example. Alcohol reacts with HCl concentrated, hydrogen chloride. This Cl over here will substitute the OH group, it becomes CCl, and the product, side product, water. Next, alcohol reacts with PBr3, this is PX3, the X can be Br or Cl. For example, here PBr3, only one Br substitute the OH group, okay, CH2Br, and the side product is H3PO3. Next, if alcohol reacts with PCl5, only one Cl substitute the OH group, CH2Cl. Side products are POCl3 and HCl. And then next, alcohol reacts with SOCl2 in the presence of pyridine. Only one Cl substitute the OH group. Here it becomes CH2Cl. Side products are SO2 and HCl. Next reaction is oxidation. In oxidation, we use oxidizing agent. The oxidizing agent can be acidified solution chromate, so anything with Cr, acidified, and Na2Cr2O7, K2Cr2O7, or CrO3. Other oxidizing agent is acidified solution of permanganate, for example, KMnO4. Next, pyridinium chlorochromate, PCC, and organic solvent, CH2Cl2. The oxidation product depends on the class of alcohol we use, and it also depends on the oxidizing agent that we use. So these three oxidizing agents are different. Some of them are mild, some of them are strong oxidizing agent. So the product of the oxidation depends on the condition of the oxidizing agent we use and the class of alcohol we use. Oxidation will only happen if the carbon which attached to the alcohol has hydrogen. Okay, if the carbon that is attached to the alcohol do not have hydrogen, then oxidation will not happen. I repeat, oxidation will only happen if the carbon which attached to the alcohol attached to the hydrogen. Let's look at the example in the next slide. So here, oxidation of primary alcohol. For primary alcohol, oxidize to aldehydes or carboxylic acid depending on the reagent. If we have primary alcohol, oxidize using mild oxidizing agent. The mild oxidizing agent here is PCC. It is pyridinium chlorochromate, that is PCC, in CH2Cl2. If primary alcohol oxidize using PCC in CH2Cl2, which is mild oxidizing agent, the product is aldehyde. If you oxidize the primary alcohol using strong oxidizing agent, the strong oxidizing agent are hot acidified KMnO4 or Na2Cr2O7 or K2Cr2O7 or CrO3. These are the example of strong oxidizing agent. The product of the oxidation of primary alcohol, the product is carboxylic acid. In conclusion, if we use the mild oxidizing agent for primary alcohol, it will produce aldehyde. If you use strong oxidizing agent of primary alcohol oxidation, the product will be carboxylic acid. Okay, here, example, we oxidize 1-butanol using strong oxidizing agent. Na2Cr2O7 here is strong oxidizing agent, acidified heat. The product will be carboxylic acid. This carbon over here, this carbon has hydrogen. The carbon that is attached of OH has hydrogen. Then oxidation can happen. Remember this, oxidation will only happen if carbon which attend to alcohol attached to hydrogen. So this carbon attached to OH has hydrogen. So oxidation can happen. This primary alcohol, we use strong oxidizing agent. Carboxylic acid will be the product. So if the primary alcohol oxidation with mild oxidizing agent PCC and CH2Cl2, if you use mild oxidizing agent, oxidize the primary alcohol, aldehyde will be formed. C double bond O and then H. Carboxylic acid will only be formed if you use strong. If you use mild, aldehyde will be formed as the product. Oxidation of secondary alcohol. For secondary alcohol, if you use strong or you use mild, both will form ketone. It doesn't matter. Okay, for secondary alcohol, you use strong or mild, both will form the ketone as the product. It cannot form carboxylic acid because this is secondary carbon. Secondary carbon is in the middle. For carboxylic acid, you need carbon at the end. So that's why you cannot form carboxylic acid if you use strong oxidizing agent. Both will form ketone. Strong or mild oxidizing agent, both will form ketone as the product. Tertiary alcohol do not undergo oxidation under normal condition because they do not have C single bond H on the carbon that has OH. If you look at here, this carbon that is attached to OH, this carbon does not have hydrogen. So that's why it cannot undergo oxidation. This is tertiary alcohol with oxidizing agent, no oxidation. This is the reason, because the carbon that is attached to OH does not have hydrogen attached to it. In summary, the primary alcohol, if you react with strong oxidizing agent, these are the example of strong oxidizing agent, the product is carboxylic acid. If primary alcohol oxidized using mild oxidizing agent, the product will be aldehyde. For secondary alcohol, it doesn't matter whether you use strong or mild oxidizing agent, both will produce ketone. For tertiary alcohol, no oxidation will occur. This is because tertiary alcohol, there is no hydrogen attached to the carbon that is attached to the OH. That's why no oxidation for tertiary alcohol.